distributions. Normal distributions is basic. Guys, come on. Normal distributions is, you've probably seen a little bit of it before. You've seen or heard of the bell curve? No.
So our math teacher's a probability of something happening.
Well, plus you talk a lot and you might miss it. Yeah, I was like things that I said today. So bell curve.
Yeah.
What happens here is that you can have data that is normally distributed. Right, the peak here is your average, your mean, if you will. Remember how you find an average?
Add them all up, divide by how many there are.
Okay. So normal distributions have this. You might see where it's skewed left, skewed right. That means the curve is moved over to the right, the curve is moved over to the left, things like that. What happens here? I'm sorry, what's that?
How can the average be higher than the average? Because the peak is the average, right?
Mm-hmm.
So how can the average be higher than the other numbers?
Aren't there more average than there are aren't there more average as opposed to outliers? Think of heights.
Wait,
I think I'm thinking of this wrong. Like,
Is this
the ones
one
on the
an
outside?
X or Y?
Those are not like all the points on, like say all the points on there. Those aren't the numbers, right? They're just like the numbers that you're adding together.
Think of it as data. What I want you to do is think of this. Somebody Google average height. What's the average height of a male?
Around our age, it's like around 5 foot.
Yeah,
The y-axis.
So this is pertaining to like what the x coordinate is?
No. This has nothing to do with X.
Oh, never mind.
Well, like, so yeah, it's the number of things that
Correct.
you would have.
It's the number of occurrences.
Yeah.
So what's average male height?
6 feet.
6 feet. Okay. So if you think of it this way, more people are 6 feet tall than they are 8 feet tall. Correct.
Oh,
that's.
Could you just do that as a bar graph?
You're making this so much more complicated than it needs to be. Just stop talking for 10 minutes, okay? Trust, then make a bar graph, okay? For the love of all things, just stop talking for a minute, okay? Trust me. These things are developed from bar graphs. Curves look nicer than angles. Seriously, who cares? All right?
Hey, I don't.
I know, but just hold your comments for a while, okay? Please, sir.
Which, the closer you are to the line, the more closer to the average.
Yes. Now, if you go through it again, if you think about it in terms of heights, the average male is 6 feet tall. That means more people are 6 feet tall. And you're right, these things are coming from bar graphs, and that was the idea of looking at some of the histograms in the past, because when you looked at some of the histograms that we did, I think I probably have one still in here. Those histograms, those bar graphs, if you curved around them, that's what these would look like. The normal curve comes from just a smooth out version of a bar graph. That's it. Okay? They call it the normal curve because curves look nicer. So what happens is that data is drawn between these sets. And there's something called standard deviation. Standard deviation, you might have talked about that in the past where you had, when you did averages, mean, median, and mode. You ever talk about standard deviation? Standard deviation is how far, it's kind of like it's a measurement against the average. How do you measure up to being average? Are you within one standard deviation, within two standard deviations, so on? But what happens here is, well, let me show you my little funny picture that I had. We had, There's normal distribution and paranormal distribution.
Wait, did you come up with that?
The internet did.
I was gonna give you props for that being too much.
Thanks.
Hey, look, it's a bar graph.
Hey, look, it's a bar graph.
Hey, look, the bars is still way easier to understand than
Megan, I have some.
Just stop, okay?
Sorry.
Please. Where these things come from is exactly, they come from the bar graph. And according to most people, it's a hell of a lot easier to draw one curve than it is a bunch of bars.
Amen.
Now, what happens is that you get binomial distributions are usually shown that they can wind up being normal. So much the data sets occur within specific parts. They get to become symmetrical above what's called the mean, the middle, your average value. And then all these areas underneath the curve are just what we call normal distribution. Okay? It's drawn from this. You look really worried.
No, I'm fine.
Okay.
I just got a little dizzy.
All right.
You got a little dizzy.
What happens here is that this is the idea of where this data sets come from. The mean, the average. Mean is the same thing as average. They denote it with an X with a bar over the top. Okay? Standard deviation is given by, I think they use these now. Is that B? I don't remember. What happens here is that all the area under the curve is 1. Think of it as probability. Probability of landing on the curve is going to be 1 because you have to be within the data sets. If you have height, you're in the data set. Does that make sense?
Yeah.
Now, what happens though is that since everything is symmetrical, half the data is on one side, the other half is on the other. Right?
Yeah.
The standard deviation comes into play is that within one standard deviation of the average, 68% of all data occurs. So between here and here is 68%.
Between where and where?
Like from bar to bar?
Oh.
Yeah. Moving within one standard deviation, it's always 68%. So if the average height is, Google that again for me here. You had the average height was 6 foot.
Yeah.
What is can you Google normal distribution male height?
Is that the reason why it says 0.34?
Mhm. Yeah, because it's symmetrical. No, that's the whole point here. It's showing that you're 0.34 on both sides because you add it together, you get.
Well, what about the graphs where like sometimes it's like, on the left side, say there's more.
That's not normally distributed, it's skewed. This is, we're looking at this up, it's gonna be normed. When everything is, you can take skewed data and norm it, but that's in a stats class, so you're not worried about it. Here we're going to be looking at pure normal distributions, okay? Or they'll say it appears to be normal, and then they can just follow the same rules. So, is there anything coming up?
I think so.
You think so?
I think so.
Okay, what do you got?
Like, what do you mean? Like a graph? Like
Yeah, do you have, is there a data, did you find any like, data of we know that the average height is 6 foot, but what does it say for one standard deviation? What are the heights at the markers?
Alright, so, well, for this side it says 70 inches is the male average height, and 65 inches is the female average height.
Alright, so we'll say it's 70 inches.
And it says with a standard deviation of 4 inches.
Alright, so your standard deviation is 4 inches, okay? So that means that the next standard deviation is 4, so did it mark it off? The next line would be at 74, 78? Is that what it was doing?
Yeah.
Okay. So then that means at 74, 78, 82, and then going the other way, you're at 66, 62, 58.
Is there ever more than 3 deviations?
I'll show you how that works as the percentages come across here. So what this says is that, is that what they were showing before or so? I want to make sure that I'm not doing it where it's,
Well, like the
Thanks.
graph, alright, so like they have the graph which goes to 5 and they have a bunch of bars that like, and it used to count like each one. I'm pretty,
yeah, that's what it looks like. That's what I'm guessing. Okay. So what's happening here is, if you think about it in terms of male height, 68% of all men are between 66, which is 5'6", and 74, which is 6'2". That's your average. 68% of all males will be somewhere within that range. Okay? If you go into the next range, we come back here, and I'll work it there. Within 2 standard deviations, 95% of all data is within 2 standard deviations. You go out 2 more bars. So what you're looking at here is you're adding in another 13.5% to both sides. So you wind up then, if I'm going back to our heights, from here to here is 95% of all males will be between 5'2" and, what is it, 6'6", 6'6". And you start to think about it in terms of men, I mean, that makes sense, doesn't it? I'm pretty sure 95% of the high school students are between 5'2" and 6'6". Yes, ma'am?
But how do you find like the differences between deviations like the 4 inches though?
We'll show how this all works. It's each thing will be different, but yet you'll have, once you know that it's normed, that means that these percentages will always occur. No matter what the problem is, whether it's within, if the standard deviation is 4, the standard deviation is 7, or whatever, okay? It'll always show that 68% is within 1 standard deviation, 95% is within 2, and then within 3 standard deviations, the last one then, 99.7% of all data will occur within 3 standard deviations, okay? That leaves you 3.3% for both of your outliers. That's for the person that's 8'2".
So ideally, you can never be 100%.
No, because it's encompassing the outliers. It's allowing for outliers to get to 100%.
And there's never going to be
0.3% left.
like there's only 3 standard deviations because
Yes.
it wants to count for the outliers.
Right, and that's where this comes from, okay? So within that last little bit, this is saying that there's less than 1% on both sides within 3, outside of 3 standard deviations. In terms of what we were looking at, if I go back here for my 3, that's 99.7% of all people are between 7 feet tall, or wait, that'd be
6'10",
6'10"
and 4'10".
and 4'10".
That's just me.
What's that?
You got your
That's just
dimensions.
male.
That's just male, yes. That's just male. That's why I just thought it'd be quick to Google that. Okay. There are other things of data sets that you can look at. That leaves off these 0.3%. So you have a 0.15% outweighing here and 0.15% going that way. Midgets and NBA. There you are. That's, I mean, lack of better terms, I mean, that's kind of what it looks like, okay? You start going through all of it. I mean, I'm pretty sure 99.7% of all males in this high school are under 6'10". I don't think there's anybody. Treelaw's not here anymore, so.
We'll see.
Is there anybody who needs a duck every single time they open the doors?
So that's where this stuff comes from. What we're going to look at is when you're working with this distribution that says that it's norm. This part right here, these values, that's what you really need to know. You need to know that 68% is 1 standard deviation, 95% is 2 standard deviations, and then 99.7% is 3 standard deviations.
So for instance, when it's abnormal, it will never follow that because it's abnormal.
Right.
It
Yeah, because it'll take, this is normally distributed, excuse me. Okay. So what we're gonna do with this kind of info is look at probabilities, okay? So the idea here, Izzy, this is really easy. You have to trust me on this. Trust me on this. Go back to heights. If I'm looking at just our height chart, if I want to say what is the probability that a randomly selected male is going to be between 70 and 74 inches tall, well, how much of the data set was in here?
34.
So what's the probability? Okay. That's all that is.
Will they ever
That
give
makes
it
so much more.
Okay? So relax. It's not that bad. All right? So if we start going through some of these ideas, a survey shows that shoppers in a supermarket are the time spent by shoppers in a supermarket is normally distributed with a mean of 45 and a standard deviation of 12. So that tells you that your average is 45. Ooh. Okay. So if the average is at 45, standard deviation is 12 minutes. Well, I just add in 12 minutes here, so it'd be 57. Add 12 minutes there, I have 69. Add 12 minutes in, I get, what, 81. Subtract 12 minutes, I get 33. 22. Okay, 21, sorry. And then 9. Man, if I'm at the grocery store for 57 minutes,
Why would anybody take that long?
let alone 81 minutes. Well, I can see if it's 81 minutes if it's like at Hy-Vee when they have samples and you're just crazy.
Oh, yeah.
That's a great one.
Now, I can see 81 minutes going grocery shopping because every single store has something else that's on sale that's cheaper than another place that you get things all over. I went to 4 grocery stores on Sunday morning.
For what?
But just because certain places have this cheaper than other places have this, and it's just easier to, instead of going to all different, the same place, I'll save money and go around and they're all on the same street.
Yeah, as long as it's not depending on our gas.
Yeah, drive to 4 different places.
If they're all, if you do it where you're going on your way to go through, it's not that bad.
If you're like going to Aldi's and then.
Aldi's got great produce. I go there all the time for my produce. It's fantastic.
I cannot freaking make cookies there.
I love
So now, when you look at this, since we know that this is normally distributed, it's asking you what percentage of the shoppers that will be at the supermarket will be between 33 and 57 minutes. Well, how far is that? It's 68%. Okay. When it goes, what's the probability the randomly chosen shopper will be between 45 and 69 minutes? Well, we knew that this much was 0.34. This whole thing would have to be 95. So half of it, what's half of 95 is what?
47.
So 47.5 subtract 34 and you get?
Wouldn't you,
I know, I'm just trying to get that little chunk in here.
Would you 95 minus 68 and then divide that by 2?
Wait, what was the
Yeah.
answer, Mary?
Yes.
Of 68%.
Yeah.
30.
It's 13 and a half more.
It's 68%.
So it's, whatever that's called, 47 and a half. Yeah, 47 and a half.
Wouldn't it be 20?
No.
What's half of
You
68%?
have to take out 60.
Oh, I know.
Yeah.
Oh, wait.
Okay. What's happening, guys, remember, you've got 68% is in that middle, 95% is within 2. Take out the 68%, what are you left with? And then divide it by, and cut it in half, because it's on both sides.
Is this all that section?
That's why he said
Is that really?
Yes, sir.
Isn't the answer A 68%?
Yeah, what?
Oh, I'm sorry, I thought I was just looking at there, yeah, I was looking at, because the next one was going that way, I thought it was just on that side, that was my fault. Okay.
Wait, so.
So within plus or minus 1 standard deviation, it's always 68%. Yes, ma'am?
So it's always those values.
Yes, always. If it's normally distributed, it's always these values. It does not change.
So for B, it would be 47.5%?
Yeah.
Yeah. Yes, ma'am.
So like say if the average was 50 and the outlier, and the standard deviation was 10, and then it says like so 50 to 55 average.
Certainly.
Where's the 13,500?
95% the whole thing, 68% is here. What's left? Cut it in
So
half.
95 minus 68 divided by 2.
Yep.
Do you get questions like that?
I don't know. I don't have the book memorized.
Oh. The same if you were to make a test, you would put questions on.
Don't know. You're killing me. I really don't. I don't remember what I wrote up for this stuff. It's been. We didn't get. You guys are actually gonna get a little bit more time in with working this than the other classes have done in the past. Let's do this just for tonight.
Oh, last year.
Do these.
Will we have to memorize
I thought this was gonna last.
You have to know that, yes. So this is what 12/7, 750.
Yeah. No, you do also.
Are we going to be doing?
Just do those, please. We'll do those for now. We'll build out of this to get a little bit more complicated tomorrow. It's not that bad. I don't want to say complicated. As long as you know these numbers, it's quite simple. Okay? As long as you know the numbers, you're going to be pretty easy. All right?
Solid.
So how bad was the other guy?
Is that 28?
What are we doing?
Was your wife just like, I'm kidding?
I felt worse for Connor.
Yeah, you couldn't make a big deal. No
Yeah.
problem.
Yeah, he was really shaken up because he saw me on the ground just going, ah!
Yeah.
I mean, I'm expensive.